Hey, it's Tuesday again. So, what you said about games and neurobiology, it might be interesting to think how you could design a game that will somehow affect the brain in certain ways. And there are people doing now neurofeedback. Did you ever hear about that? It's used to help with ADD or ADHD. I'm not sure. The idea is that you need to play a game, and during the game, some electrodes read the activity of your brain, and the game directs you toward a certain brain activity pattern that would lessen the ADD. I'm not an authority on that, so if you want, I can look into it. But other than that, you could think of how a game would stimulate your brain in such a way that will be, I don't know, kind of more fun, more challenging. So, what is it that I do? Well, I am working toward a PhD, and in Israel that's called a doctorate. That might have got you confused. It takes about 4 years usually, if you're a theoretician, less. If you get into problems with the experimental stuff, then it might take more. I belong to 2 lab groups. This is a little unusual. It's not the common way. I have 2 advisors. Each advisor is a professor that guides me in my work. One of my advisors supplies most of the facilities, like the devices, like a 2-photon microscope, genetic methods, and stuff like that. So he's on the more technical side. And my other advisor supplies the more scientific side. What do we actually do? We study this part of the cortex. The cortex is the kind of outer layer of your brain. Yeah, the mantle of the brain. And it performs a lot of the information processing in the brain. We look into a specific area in the cortex that is the first station in the cortex that gets information about sound. It's called the primary auditory cortex. No one actually knows what it does. All the processing of what stimulus it was, what key on the piano, for example, that was processed in the lower stations, in the brainstem, and so on. What we think the auditory cortex does is extract the statistics on the environment. So it will tell you what's unusual and what's surprising. As always with science, what we do eventually is go into a very little thing and study that and think that it will tell us about the bigger things happening. So basically we study how the neurons in this part of the brain react to surprising stimuli, to surprising events. And so you take it down to the simplest level, and you have a tone that repeats itself many times, and every now and again you have a different tone coming. Neurons in your brain respond more strongly to that deviant tone, and even when you're not concentrating, and even when you're asleep, they do these things for you subconsciously. And we're trying to see what mechanism does this. Okay, that's it for now. You're welcome to ask questions. Actually, there's no time left for my own questions, so you'll just have to volunteer the information. Bye!